Hello. So today we're going to talk about the factor theorem and how to determine the factors of a polynomial of degree 3 or greater. So as you know, if we have a quadratic or if we have a degree 2, we can always find a factor by doing sum and product or by difference of squares. So when it comes to degrees higher than degree 2, we can't use these processes. We have to actually find the factors. And we have to use long division or synthetic division to factor. So first of all, we need to find the factors. And a factor is something that when I divide the polynomial by, I will get a 0. That will be my remainder. The remainder will be a 0. So in order for me to find if something is a factor, I need to use the remainder theorem to determine if it is a factor or not. So the first question here is asking you, use the remainder theorem to determine the remainder when f of x is equal to x cubed plus 4x squared plus x minus 6 is divided by x plus 2. So remember, with the remainder theorem, we said to determine the remainder, I have to plug in the factor, which in this case, the factor is -2. And then once I plug in this into my equation, I can find what my remainder is. So the answer would be my remainder. So we covered that in the previous lesson, and this is how I find what my remainder is. So I plugged in -2 in for x, and I'm getting -8 plus 16 minus 2, take away 6, and that's going to give me f at -2 is equal to -8 minus 6. So minus 2, that's -16, plus 16, that's a 0. So you see here that when I plugged in -2 into my f of x, I got a 0. And that means x plus 2 is a factor of x cubed plus 4x squared plus x minus 6, which means that when I divide the f of x by x plus 2, I'm going to get a 0. Now let's see if that's true. Let's see what happens if I use the long division. Let me just write the sentence. So the remainder, so in this case, I use the remainder theorem. The remainder when f of x is divided by x plus 2 is 0. This means that x plus 2 is a factor of f of x. Okay, so when you use the remainder theorem, you plug in the 0 of the dividend of the divisor. When you plug in the 0 of the divisor into the function, and you turn out to have a 0 as the remainder, then you know for sure that this is a factor of f of x. Any other number other than 0, then it's not a factor. Press the wrong button here, 1 second. Now let's verify by completing the division using long or synthetic division. So I chose synthetic division since it's a linear divisor of the form of x minus b, okay? So I'm dividing by -2, and then my coefficients are 1, 4, 1, and -6. So -2 Negative 2 times negative 2, that's 4. If I add 4 and 4, that gives me 8. 8 times negative 2. Oh, I don't know why I wrote negative 2 here. Let me just erase this 1 second, guys. Sorry. I made a big mistake. I wrote negative 2. When I bring the 1 down, it's a 1. 1 times negative 2, that's negative 2. 4 plus negative 2, that's 2. 2 times negative 2, that's negative 4. If I add, that gives me negative 3. Negative 3 times negative 2, that's 6. If I add, that's a 0. So you see this here is a 0. That means my remainder is a 0. So if I'm going to write my equation, x cubed plus 4x squared plus x minus 6 equals to x plus 2 times x squared plus 2x minus 3 plus 0, which I do not need to write that. So you see now I'm starting to factor here. Yeah? So I have my first factor, and then my second factor is a quadratic. We'll talk about that later. So along with the remainder theorem, we're going to talk about the factor theorem. So the factor theorem says x minus b is a factor of the polynomial p of x if and only if p of b is equal to 0. Right? So if when you do the remainder theorem and you end up with a 0, then you know it's a factor. Similarly, if you have ax minus b, it's a factor if p at b over a, so remember that you're going to bring the b over, divide by a, is equal to 0. So to determine if x minus 3 and x plus 2 are factors of p of x equals x cubed minus x squared minus 14x plus 24. So to determine if they are factors, all what I have to do is I set x minus 3 equals 0, then x equals 3, and then I'm going to plug in 3 in for x. So I'm going to find p at 3. So that's going to give me 3 cubed minus 3 squared minus 14 times 3 plus 24. And that equals to 27 minus 9 minus 42 plus 24. And what do I have here? Negative 42 minus 9, that's negative 51. 24 plus 27, that's 51. 51 minus 51, that's a 0. Since the remainder is 0, then x minus 3 divided evenly into p of x. That means x minus 3 is a factor of p of x. Okay, now we're going to see the x plus 2. So I said x plus 2 equals 0. That means I'm looking at x equals negative 2. I'm looking at p of negative 2. Let's plug in negative 2. So what I have is negative 2 cubed minus negative 2 squared minus 14 times negative 2 plus 24. And that gives me negative 8 minus 4 plus 28 plus 24. And you can see right away here, this is too big. So I have 52 and then minus 12, and that's going to be 40. So since the remainder is not 0, x plus 2 does not divide evenly into p of x. This means x plus 2 is not a factor of p of x. How to determine a factor of a polynomial with leading coefficient 1. So in this case, they've been giving us numbers and they've been asking us to find if it's a factor or not. So to determine, you could guess and check values of b that makes p of b equals 0 until you find one that works. Or you can use the integral zero theorem to help. So the integral zero theorem, if x minus b is a factor of a polynomial function p of x with a leading coefficient of 1 and remaining coefficients that are integers, then b is a factor of the constant term of p of x. So that's what the integral zero theorem means. So let's say you have, if I'm looking back here, right? If I'm looking for the factors, I'm going to look at my constant, which in this case, my constant is 24. And I'm going to have to list the factors of 24, and I'm going to try the factors of 24 and see which one of them works. 3 is a factor of 24, right? 2 is a factor of 24 as well, and negative 2 is a factor of 24. But this time, 3 works, negative 2 does not work, because not all of the factors will work. Note, once one of the factors of a polynomial is found, division is used to determine the other factors. Okay, so I only need to find one. Usually starts with the small ones. Now remember that we're talking about leading coefficient of 1 in this case, because if the leading coefficient is not 1, then we have a different method to follow. A similar method, but a little bit different. So, factor x cubed plus 2x squared minus 5x minus 6 fully. So p of x that we have in this case, x cubed plus 2x squared minus 5x minus 6. We're going to find the value of b such that p of b equals 0. Based on the factors theorem, if p of b is equal to 0, then we know that x minus b is a factor. So we can then divide the p of x by the factor. So, the integral zero theorem tells us to test factors of, what's your constant here? So the constant is negative 6. So we're going to have to find the factors of negative 6. So the factors of negative 6 are, it doesn't matter if negative or positive. So positive and negative 1, positive and negative 2. So I'm looking for numbers that divide 6. Positive and negative 3, and positive and negative 6. Okay, so we're going to start testing all of them. You start testing the positive, you start testing the negative. There's no way that you can tell unless you test, guess and check. Okay, so we're going to start. In this case, we chose 1 to start. So let's start P at 1. So I have 1 cubed plus 2, 1 squared minus 5 times 1 minus 6. So 1 plus 2 minus 5 minus 6. You see that this is going to be negative. So that's not going to work because that's not going to be 0. It's going to be negative 8. Since P of 1 is not equal to 0, then we know that x minus 1 is not a factor. Now, let's try 2. So I have 2 cubed plus 2 times 2 squared, that's the squared, minus 5 times 2 minus 6. So that's 8 plus 4 times 2, 8, minus 10, minus 6. I have 16 minus 16, yay, it's 0. All right, so now I know that since P at 2 is equal to 0, we know that x minus 2 is a factor of P of x. So that's good. The faster I can find that factor, the faster I can go on with factoring, okay? So we can use either long division or synthetic division to find the other factors. So now I know my factor, now I need to divide, okay? So let's try with both of them. So I have x cubed plus 2x squared minus 5x minus 6, and I'm dividing by x minus 2. If I divide x cubed by x, that gives me x squared, and then I can multiply x squared. So I'm multiplying here, x squared times x is x cubed. X squared times negative 2, that's negative 2x squared. And I'm going to subtract. So the x cubed cancel each other. 2x squared minus negative 2x squared, so that's 4x squared. Bring down the negative 5x. So if I divide 4x squared by x, that's going to be 4x. So that's 4x squared minus 8x. Let's subtract. Cancel each other. Negative 5x plus 8x, that's 3x. Bring down the negative 6. So now I have to multiply, divide 3x by x, so that's 3. 3 multiplied by x is 3x. 3 multiplied by negative 2, that's negative 6. I can subtract. So the 3x are going to cancel. Negative 6 plus 6, that's going to be a 0. Yay! So that's my factor. So now I have to write my equation. Let's write that. So I have x squared, x cubed plus 2x squared minus 5x minus 6 equals 2. X minus 2 is one of my factors, and then what I have left is x squared plus 4x plus 3. So you see that this one here, the x squared plus 4x plus 3, that's not factored fully, right? The question says factor fully. So now I still have to factor this, but this is quadratic. So now it's easy to factor it. So I'm looking for two numbers that multiply, if possible, you can factor it. Looking for two numbers that multiply to 3 and add to 4. That's 3 and 1, right? So that means that right away I know that I can factor this to x minus 2, x plus 3, x plus 1. All right? Now we can try the synthetic division. We should end up with the same answer. So my factors here, and then my factor is 2, and then I have 1, 2, negative 5, and 6. Bring the 1 down. I'm multiplying. 1 times 2 is 2. And I can add. That gives me 4. 4 times 2, that's 8. Add, that gives me 3. 3 times 2, that's 6. Sorry, I have a negative here. 6, negative 6 plus 6, that is 0. A remainder of 0. Perfect. So now I can do the x cubed plus 2x squared minus 5x minus 6 is equal to x minus 2, and then x squared plus 4x plus 3. And that equals 2. I can factor this further if I can. Again, multiply to 3, add to 4. So that's x plus 3, x plus 1. All right. So what I want you to do is I want you to try example number 3, and I will post the solution for that one. I will not record myself for that one. I'll post the solution for that one online. If your answer is more than quadratic, so if your answer is cubic, for example, if your quotient is cubic, then you might have to do a couple long division or a couple synthetic division, okay? Like the next example. Then you're going to have to find the factors again, and then you're going to have to do another synthetic division, okay? You'll see that you're going to see that I have a couple of synthetic division in the next question. Actually, I will record a video for the next question, but I'll give you some time to do it first, and then